Maintenance training. In 10 minutes, we will cover the basics of what you need to know in order to work on ACs, starting with troubleshooting. Diagnosing units will require some hand tools, and they are essential in order to perform the work, so get the correct tools. You will need a set of gauges that are compatible with R410A, a multimeter that can read capacitance, electrical pliers, preferably with a crimper, a 6-in-1 or 11-in-1 screwdriver, a drill with drill bits, a refrigerant key to remove locking caps, and I highly recommend this voltage and temperature meter by Klein. Every service call should begin with these 4 steps. This will set you up to diagnose correctly what is wrong with the unit and move forward with the repair. If a service call starts off with a thermostat not responding to anything and not lighting up, the first thing to check would be the power switch. Make sure that it is in the on position so the unit can respond. Next to check would be the float switch. This prevents the unit from running if this reservoir here gets filled up with water, and this floater will cut off power to the unit. Some units without a gravity drain will have this condensate pump that has a built-in float switch. If there is an issue with the drain, likely the drain will have to be cleared out using nitrogen or some sort of pressurized air. Moving on to the actual furnace, there is a door switch that prevents the unit from running if the front panel is missing. To the left of the door switch is a 3-amp fuse that will pop out in case there is a short on the low voltage. Speaking of low voltage, the next part will require a multimeter in order to test the transformer. The transformer actually has 2 voltages. The primary voltage, or the high voltage, in this case 120 volts, goes into the transformer, and coming out will be low voltage or control voltage at 24 volts between the blue and yellow wire. If you have high voltage going in but no low voltage coming out, the transformer will need to be replaced. Next step in diagnostics is fan on. Simply go to the thermostat, put it on the fan on setting, and immediately the fan should respond. Within 10 seconds, you can find out 4 things: that you have high voltage, low voltage, the unit is responding to the thermostat, and your blower motor is functioning. Step number 3 is temperature split, or delta T. This is very, very, very important in air conditioning. You're typically looking for a temperature split between 16 and 20 degrees. The temperature split can be found by taking the return air temperature and subtracting the supply air temperature from it. If you're not within that range, the next thing to check is number 4. Check the filter. It's very important. A dirty filter can heavily impact your refrigerant pressures and overall the ability to cool, which is the next section, cooling. Gauges are to be installed like this. The blue line goes on the thicker low side, and the red line goes on the smaller copper line, which is the liquid line or the high side. In order to read gauges, we must get acquainted with them. The way they work is the outside numbers are the PSI. This blue gauge only goes up to 350, while the red gauge goes all the way to 800. So the blue gauge is the low side, red gauge is the high side. The gauges used in this example are for 3 refrigerants, R22, 410A, and 404A. We're mainly going to focus on the 410A section of where these needles end up. Since we're focusing on 410A, we go to where the needle is, and we see in the black numbers it's just between 70 and 80, indicating 75 degrees saturated temperature. The gauges show the correlation between pressure and temperature. As the pressure goes up in the PSI, the temperature also goes up, and it's different for each refrigerant. For example, if I put a temperature gauge on a refrigerant tank and it's 75 degrees, I know that the saturated temperature of 75 degrees is 215 psi. These characteristics of the refrigerant are applied to our pressures and temperatures on the gauges. So we take the indoor temperature and subtract 30 degrees from it, and that is our target temperature for the low side, and we take our outdoor temperature, add 30 degrees to that, and that's our target temperature for the high side. Here are pressures that will resemble actual real life scenarios. So on the low side, you see the saturated temperature of 410A is at 40 degrees, indicating the indoor temperature should be around 70 degrees. The high side, the saturated temperature for 410A is at about 104 degrees, indicating a 74 degree outdoor air temperature. By knowing both the indoor and outdoor air temperature, you have a target or an idea of where your refrigerant pressures and saturated temperatures should be before you even hook up your gauges. If a charge is needed to be added, only charge based on the high side. So add 30 degrees to your outdoor temperature, and that'll get you just about where you need to be on the low side. Also, 410A must always be charged with the refrigerant tank upside down, as it is a blend of refrigerants, and as a liquid, it comes out in its purest form of 410A. As a vapor, it does come out with the lightest refrigerant first, so always flip the tank over. Now that you know where your pressure should be, you can use this chart to help you diagnose further what the issues could be, based on what the low side and high side give you. Before hooking up your gauges, you will need this refrigerant key to remove the refrigerant caps, as they are installed in every single unit. Again, the blue line goes on the bigger suction or low side, and the red line goes on the smaller liquid or high side. If a unit isn't cooling and you hook up your gauges and find the temperatures to be at the exact same thing, the next thing to check would be the capacitor. The capacitor is an electrical component, so it's important to remove the disconnect. You want to avoid electrical shock at all costs. And even after removing the disconnect, the capacitor has to be discharged by putting a screwdriver over all the leads. The capacitor can take 240 volts and produce up to 440 volts. So it is very important to be careful around these and turn off the power. Once removed, the capacitor can be tested by this setting here, which is capacitance, also known as microfarads, as indicated by this weird looking U and F. Once on this setting, you can test the leads between common and fan to get the fan side of 5 microfarads and switch over from common to Herm in order to get the Herm or compressor side at 25 microfarads for this particular capacitor. The capacitor leads can be identified by the letters of the capacitor or by the number of prongs. The common usually has 4 prongs. The Herm or compressor side would have 3 prongs, while the fan side would have 1 or 2 prongs. Different brands use different identifiers, so always be sure to test it before you install it. If the outside unit is still not responding and the disconnect is on, the issue could be within a fuse just under the main meter. The last section is heating. In this case, we have gas furnaces. The inducer fan motor is the first thing to turn on, and it's the thing I'm pointing at here with my laser. Once the fan proves airflow through the pressure switch, the igniter glows bright cherry red as it's energized. It is only held by that one screw back there, and it's mounted directly in line with the burners. There is a ball valve just outside of the furnaces that will cut off the gas supply in case you need to service the unit. There is also a switch on the front of the gas valve to turn off the gas valve. Once the flame comes on, the unit will have a bit of a delay to turn on the fan as the heat exchanger heats up. If the flame goes out of the unit, there are these rollout switches that need to be manually reset by pressing that black button in the middle. That protects the system from overheating. By removing this wire, I am simulating a bad or a worn flame rod. The flame rod needs to be checked periodically if the flame does go out. It can be removed by taking off this top screw here. It's a 1/4 inch screw, and the sensor can be cleaned using sandpaper. In order to diagnose a furnace, it's very important to get the order of operation or the sequence of operation. First, the inducer fan motor starts up and improves airflow by this negative pressure switch. Then the igniter will glow bright cherry red before cycling on the gas valve. When the gas valve finally does cycle on, you're looking for a bright blue flame. If there's any specks of yellow or orange, it indicates a dirty flame. The unit will attempt an ignition cycle 3 times before going off on ignition failure. The unit does have an alarm code indicated by this red LED light. The number of blinks indicate the problem that the unit has, And on the back of this door cover, it will tell you what blinks mean and what to look for in order to make the repair necessary.